Well, good morning, everyone, and thank you so much for joining Accelerating Decarbonization, Windows and Facade Solutions. My name is Larry Katz. I am an energy engineer on the NYC Accelerator program. As many of you know, NYC Accelerator supports building owners and managers to identify energy cost-saving projects, including near-term retrofits and major system upgrades. To help transform buildings to low-carbon operation, the Accelerating Decarbonization webinars are intended to inform stakeholders of ways to significantly reduce energy use and carbon emissions. Today, we have 5 solution providers with different approaches to improve window and facade performance. Please note that you can enter questions along the way in the Q&A box, and we will get to as many questions as possible following the 5 presentations. Contact information for the presenters and links to the presentation and webinar recording will be sent in a follow-up email. I want to thank our presenters for their time and efforts to prepare and deliver information. For your knowledge and consideration, we have speakers from Adler Windows, Solar Solutions Window Tinting, InnoView's Dextel, and Hydronic Shell Technologies on the agenda this morning. And with that, I'll now introduce Hugo Ramirez from Adler Windows. Hugo, please unmute and take it away.
Good morning, Larry. Can you hear me okay?
Yes, I can. Thank you.
Great. Thank you so much for having us today. My name's Hugo Ramirez with Adler Windows. We are what you call a local dealer installer here in New York City for Windows. I've been given 8 minutes, so I'm hoping to respect the 8 minutes. We're going to go through a brief overview of Windows, New York City, our company, and the like. So again, Hugo Ramirez with Adler Windows. Next, please. Next slide, please. Okay, I think there's a little bit of a delay. Great. We'll stay here. Thank you, Larry. Adler Windows has been around since 1986, so we're hitting almost 40 years. We're local to New York City, family ran and operated. We've completed over 4,000 unique addresses within New York City, so we're very comfortable in New York City. As tough as it may seem, it's a very big undertaking to remove and install lift windows here in New York City in some of our tight quarters. And we have roughly about 90 people swinging hammers any given day, whether it's a new construction project, replacement project, or just a service project. We're really big on core values, so I'll go through them really quickly. Our top 5 are safety always comes first, lead with solutions, do the right thing, dedicated, and most importantly, own it. Next slide, please. These are the markets that we cover: commercial, custom, landmark, residential, institutional. And just to kind of bring you up to speed on the commercial side, or on the new construction side, we've done projects with L&M Development, Cindero Verde, which is the largest passive house project. And Jim McGordy later on will talk a little bit more about Dextel, which is a sister company. And on the replacement side, we have a 5-year rolling project with Rockefeller Center. Every time a unit needs to come out, we fabricate a new window and we put a new window in. And then we have a small service division that essentially just changes out glasses, balances, and the like. Next slide, please. So understanding window efficiency. So why are windows so important? It may sound like a silly question, but if you just look up in our small town of New York City, whether you're Manhattan, Bronx, Queens, there's a lot of windows. And with a lot of windows, the surface face of the building itself carries a lot of windows. So if you can see here on this building here, Greenpoint Landing, that is a lot of windows, a lot of glass, a lot of metal. And essentially, if your windows are not performing, you're losing a lot of energy, and costs are essentially going out the building. Some of the trigger words that may be helpful for you as you're undertaking or evaluating your building or looking at windows to replace is something called U factor. It's a rating of the energy that performs for the window. Solar heat gain coefficient, also known as SHGC. That is actually the heat or the energy that is transferred through the glass itself. And let's go through some of the benefits of window replacements, right? So you have improved energy efficiency, lower energy consumption, which leads to lower or reducing your costs, enhancing indoor comfort, whether it's energy or acoustical, right? So when you're replacing these windows, we're not just looking at energy. In our loud city, we're also accustomed to looking how do we better soundproof our windows as well. And then we're reducing HVAC systems or loads. And then again, we're also increasing property values. So essentially, we're not just trying to save money, you're also increasing your property values. Next slide, please. So a little bit further, or drilling down a little bit on window technologies, this may sound a little rudimentary to some of the professionals that are on here, or this might be something new for people, right? So what we see a lot in our city is single glazed units, which means it just has one piece of glass. With the newer technologies, there's double and triple glazing. There's units that can injected with gas, which essentially what we call the invisible sweater of windows. Low E coatings, and low E coatings can be single, double coatings to again, and the best way we can explain low E coatings, again, from a rudimentary standpoint, low E coating is essentially the sunglasses that we put on windows to reduce that energy transfer. OITC stands for outside inside transfer, which is also laminates. So in that, not just talking about energy, but again, you're soundproofing your windows as well. And then smart windows and auto tinting. So I think we have somebody that's going to be on the panel later today talking about smart windows, but that energy or that technology is up and coming, and it is taken by wild here. Next slide, please. So overcoming challenges and considerations. What are the barriers for replacing windows here? So time in itself, it can be as long as 10 years. We're working with condos and co-ops here in New York City that takes them about 10 years to evaluate different window systems, who's going to go first, what type of windows, operation. We can also be encountering not just energy or Department of Buildings initiatives, we're also looking at landmark requirements. So that can also complex things here. Initial investment costs, right? There's soft and hard costs. Some of the hard costs can be some mock-ups that we need to probe some of these windows or some of these openings, fabricate a mock-up, install a window so everybody can see what's going on. Some of the soft costs, consultants, energy consultants, architects, owner representation. So there's some of the soft costs that go into that as well. Budget constraints. A lot of the reasons why people come to Adler Windows is we don't fabricate any types of windows. We go to a multitude of window fabricators, whether it's locally or internationally, and we rely on the window manufacturer or together with the manufacturer to promote and propose the correct window system for that application. Challenges in retrofitting older buildings. As you can imagine, some of these older buildings are really tough to pull a window out and install a new window. Some of these hallways, some of these smaller studios is really challenging to navigate some of these larger windows into these spaces. We've been doing it for close to 40 years. We're very well equipped and very experienced in that nature. And the importance of choosing a reputable manufacturer. So what we say here at Adler Windows, product performance is really driven by the window installation. There's a lot of really good window systems out there. Unfortunately, a lot of the systems fail is due to the lack of proper installation or proper maintenance of the system. Next slide, please. I'll go through, I think I only have 2 or 3 slides left, and I think I'm doing okay with time. This is a project over in Brooklyn, right by the Barclays Center. This is called the Brooklyn Grove. I'll start speaking about a manufacturer called Peerless out of Fort Scott, Kansas. This is a European style system that had a very energy efficient style window, as a casement style, which swings in and out, and also had an acoustical rated system as well. So not just really great on energy, but also really good on acoustics, which is more for the soundproofing requirements. Next slide, please. And a beautiful project here. This is called Cindero Verde, which is the largest passive house project in America, right here in our hometown, our home city. This was a system developed and produced by a company called Intis, which is using super passive house design coming in from Lithuania. So it is coming from overseas. And we put in a lot of windows here. It's a UPVC system, very high energy efficient window system. And next slide. And just to conclude here, that's another pretty cool project. That's called the Paragon Building over in Long Island City. That's a reposition project with Related. We pulled out all the old factory windows, put in energy and acoustically rated windows by Peerless. You might be able to see this building when you're on the LIE going right before the tunnel here. So environmental impact, reducing energy consumption, reducing greenhouse gases with window replacement projects. The financial advantages, energy savings and increasing property value, improving comfort and occupied well-being. And lastly, we're here to help. My name's Hugo Ramirez with Adler Windows. If there's anything we can do, my number's on the bottom of the screen, and I think there's a Q&A later today. Thank you very much, Larry.
Hugo, thank you so much. Much appreciated. Just moving on now. I'd like to introduce Cindero Izzo from Solar Solutions Window Tinting. And if you would, please take it away, Cindero.
Thank you. Good morning, everyone. So I am the CEO of Solar Solutions, and we've been around since 1984. We've been installing all types of films, from energy control films, security films, graffiti films, decorative films of that nature. We service the residential and the commercial sector as well. We have two locations. We have one in New York City and also one in Long Island, New York. Next slide, please. So just to touch base a little bit about, and we just heard it actually from Hugo, so we're very similar as far as the characteristics of glass. We inherit the natural light that comes through to give us a nice, excellent view of our, on the exterior, whether it be you live on the waterfront or just the beautiful city. But unfortunately, it inherits problems. We get excessive heat, and on the residential, even on some commercial, where we have some fading of some furniture, carpeting, artwork, things of that nature. And also some people that are prone for some kind of skin melanoma. You have to be careful with the UV rays. Next slide, please. So with Windows, of course, we all know that what causes some of the issues, the heat load that's coming in. And a lot of the chillers, some of the buildings in New York City are not up to par, and they struggle as far as trying to cool down certain spaces, or they're undersized as well. With some of the window films, we could actually help in that sense, just lower some of that, the therms coming in. Next slide, please. So in our industry, there are several different types of technology. The older technologies are the dyed window films. If you remember them years ago, after they fade after a certain period of time, they turn a little blue and purplish after they fade. They offered very little performance. They had a short life expectancy, and it wasn't really favorable. It kind of gave the industry a black eye over the years. But as time went on, technology has gotten better, more advanced films. So they came out with metallic films, which offers a pretty good heat rejection. The unfortunate thing is that sometimes it's not all that nice. Some people don't like that mirrored-like look on the glass. But the life expectancy has increased, quite a bit from the older technology of the dyed films. And then probably about 20 some odd years ago, Hooper Optic came out with a patented technology of ceramic window films, which offered a much higher heat rejection. It was neutral in color, so it didn't really look like anything was on the glass. And it came also with a heat rejection of up to almost 90%, which is a great deal. And then also the spectrally selective films, which we consider our Bentley of window films. They offer the highest heat rejection, where we could actually get 90% IR heat rejection out of this particular window film. And they're virtually clear, so it looks just like glass. There's no reflectivity, so it's equivalent to glass, where glass is somewhere between 10, 12%, I guess, somewhere around there about reflectivity. So it's just the same. Life expectancy of the film is 28 years plus. That's the good news. We've been installing this film almost about 30 years now, and I still have customers that is on the glass and still performing very well, which is really nice. Some of the pictures that you see on the board there, just to show you what the films look like on the dyed films, how it's got that dark look. The metallic films, if you look at that, it has that metallic look on the buildings. And the ceramic and the spectrally selective on the that you see there in the photographs, they can be virtually clear. And the last picture that you see there is actually a marquee project that we did a couple of years ago. It was the Museum of Science and located in Boston, and we saved them a tremendous money just installing this particular window film, because they couldn't cool that space down enough, because they didn't have enough space to get a larger cooling system. So we helped them out with that a great deal. Next slide, please. So we get clients that ask us, could you quantify your numbers? And yes, we can. We actually data log glass buildings and stuff like that. And then we also work with our distributors, our manufacturers, and they can actually give us an energy audit on how well that window film performs on that type of glass, and also give you an ROI report. It's a very detailed report that that happens with that. So it's really cool. And we could also do multiple films. So some people are at different price points with films. We could also offer that as well. Next slide, please. So just basically about the benefits of window film is the costs and savings, reducing the heating and the cooling loads, peak demand reduction. That's a big thing that's been going on for a number of years. Improve resident, and that also should be as commercial comfort as well. A lot of commercial people, they have offices right by a window, and it's extremely hot there, and it's very uncomfortable. By the glass area, without window film, it could be upwards of 100 degrees. With our window films, we could actually reduce the temperature somewhere between 12 and 15 degrees cooler at the glass area, and that's not including any kind of re-radiation of things that are surrounding that glass area, whether it be mullions or marble or anything like that. But even on the residential end as well, a lot of people now are having their home offices, and they put their computer desk by their windows for better view, and it'll keep them much more comfortable there. Overhead reduction, asset protection. It's a combination of things where if those chillers are not working as hard, it'll be less maintenance on that system. And also a lot of like hospitalities, industries and stuff like that, where it helps protect as far as any kind of fading and of their furniture or things of that nature. It helps in that asset. Since the films are virtually clear, we could also create that natural look coming through, so you won't cloud it up with a dark window film. So we try to maximize as much light coming through, but still have the protection, whether it be from UV or just the IR, or make that building much more comfortable. And there is some programs out there for the utility companies, and also on the federal tax end of it on the residential side, where there are certain window films that are eligible for federal tax credits as well, and that has to be determined on which films you use, if you're eligible or not. And I believe that's it for me. And this is just some bragging rights on some of the commercial businesses that we've done business with, and we love doing business with these partners, because they call constantly when they open up new locations and stuff like that. And we always love to partner up with good people, good companies. And that's it. I really appreciate everybody for listening, and thank you all on the panel for listening. Have a great day.
Cindero, thank you so much. I'll now introduce Tom Burke with InnoViews, give a presentation. Tom, if you would, please go ahead.
Thank you. My name's Tom Burke. I'm the Business Development Director. I reside here in New York City. We have an office here in New York City. We are a Texas-based company. We've been around since 2017. We are a window retrofit technology company. Next slide, please. So I think this slide really needs no introduction, but it really shows what's happening with the facades pictorial here of New York City. But we are trying to change behavior. We're trying to get companies and folks to now look at the facade versus running to the mechanical room. So you see the size of the problem, you see energy loss through the facade, but you also see the cost as it pertains to if we are going to get to the decarbonization effort, it really needs to start with the facade. Next slide, please. So InnoViews comes into the marketplace with two different types of technology. We have on the left-hand side what's called the IGR. So what we do is, in this case, you have a cutaway of a single pane window. And what we do is we will retrofit that existing piece of glass. So by using our patented support spacer frame technology, we measure up the window, we clean the window, and we deliver directly to the site the pre-measured support spacer frame. We adhere it using structural glazing material directly to the glass. And then we ship to the site a factory-made IGR that's lifted into place. We put desiccant packing material tubes inside the support spacer frame, lift the new IGR into place, and then caulk it into place. So this now becomes a hermetically sealed unit. You can think of this as the IKEA. There's no disruption, there's no drilling. We do not alter the existing facade or alter the existing window. This can be installed directly on the exterior or the interior. It's also part of the CNI program within New York City. The way we work is we do a holistic view of the building. We'll come in, do a building walk, gather all the utility information, and do a cost-benefit analysis. We approach the market as a ECM, an energy conservation measure. Using the IGR, we see about 28% noise reduction. So that's a byproduct of basically assembling a new IGU on site. The second technology we have on the right-hand side is called an interior SWR. And this was born out of a building we did here in New York City for tall, thin windows. In this application here, we installed directly, again, on the interior only. We use the exposed frame, and we basically build a secondary window, again, ship directly to the site, again, clean the window, measure up the window, Everything is prefabricated off-site, so there's no dumpster required here. Directly adhere it to the existing frame, seal it in place, and that becomes basically acts as a double pane in this case. We are agnostic to what kind of glass the owner wants to put on site. We usually make 3 recommendations based upon the existing glass that's already in place. Again, there's no disruption here. We usually do installations like this off hours, so it's not a non-disruptive installation. On the exterior installation, we can do it while tenants are already on site. Next slide, please. So this is an installation we did out in Portland, Oregon. It's one of the largest installations we did using our IGR. We actually took the existing double pane windows and turned them into triple pane. So, and kind of when we went through the M&V process here with this installation, it came back that the utility had measured the noise reduction. And one of the reasons why this customer had purchased and wanted to take double pane to triple pane is because they are across the street from a train station, and the tenants visibly had seen a massive reduction of the outside noise. So we had utility M&V done on this installation. We're through that. Probably what we've seen so far, roughly about a 12 to 18% reduction in their utility spend through the whole process here. So you have new glass, an insulated cavity, a thermal break, and sound insulation. Next slide, please. So as I talked about, we're kind of agnostic to what kind of glass the owner wants to put on the building. What you're seeing coming into the marketplace now is transparent photovoltaic. We can put transparent photovoltaic on the vision glass. We could put densified PV on the spandrel glass on the exterior. You're seeing self-cleaning glass come into the marketplace, which allows the owner now to upgrade where you can have a chemical reaction with the rain. VIG is also coming into the marketplace. In some cases, you're going to see VIG that can be put on the exterior of a building now to take single pane and turn it into triple pane, and actually take an R value of single pane window that has an R value of 1 and potentially turn it into an R value of 5. And then my favorite, which is dynamic tinting glass, which we've done a project, I think in the next slide here that we could show you. Next slide, please. So this is a project that we did roughly 3 years ago in LA at the Regatta. And it was the first time we had integrated dynamic tinting glass. And this, as a couple of the presenters talked about, is the sunglasses of glass. And I think this type of technology has taken the marketplace by storm. Again, using our IGR technology, no disruption. We do not modify the facade or the existing glass at all. And it's a quicker way to bring technology into the marketplace. So this allowed the owner to take a look at a different type of option. Next slide, please. This is a pilot project we did here in New York City on the Avenue of the Americas. We're through roughly about 9 months of the project. Here, it's roughly a $6.9 million project. We've seen so far, when we did the calculations, roughly 28% reduction in heating, 12.2% in the EUI. Simple payback is under 7 years, 6.8-year payback. We did a cost benefit study. Again, what we do when we holistically come into the building is look at the facade first, the perimeter heating, the mechanicals, take all that information back and basically build a model from the ground floor up, so we can actually simulate what the energy savings would be. We also do the submittal back to the utility, localized utility, and present to them a case for incentives and what incentives are available here in New York City under the C&I program. Next slide, please. So the metrics around this building was we were seeing anywhere from a total utility savings of about $675,000, but most of it was on the steam side, which reduction was about 28%. But the other thing that the owner and the PMO had put forth to us was a decarbonization plan regarding about the effectivity of doing the windows here as it pertains to local law 97. And we actually saw a reduction in their penalty from, in this case, would start in 2030 and take it out to about 2050 of anything north of $4 million in penalty avoidance. We are one of 3 metrics for ECMs in this building towards decarbonization. So we do also do and present a study around this as a metric for decarbonization here in New York City. Next slide, please. So we provide a no-cost benefit analysis on a building. Again, holistically come in and look at the energy savings, what utility incentives are. We make a recommendation as to what we see at the facade when we do walk the building. Again, go through the mechanical rooms. We actually take back the information that they give us regarding any of the ECMs that they already have in place. And we'll make a recommendation as we see it from the facade perspective. It's a free cost benefit analysis, and we take the data back by doing a survey. We are one-stop shopping. We work with localized glazers for installation and certify them from a factory perspective. Thank you.
Thank you so much, Tom. Okay, moving ahead, James McCourty is with Dextel, and James, if you would, it's all yours.
Thank you, Larry, and thank you all for attending today's webinar. My name is James McCourty. I'm a Senior Business Development Director at Dextel, and I'm joined here today by my colleague, Alexandra Zatorska, who's head of our product for Dextel Studio. Dextel is a vertically integrated construction technology company. We manufacture unitized prefab wall systems for mid to high-rise buildings in both new construction and retrofit applications. And our mission is common with all of you, and that's to accelerate the decarbonization of the built environment and achieve our climate goals through efficient, affordable, and sustainable solutions. Next slide, please. As we prevail in both new construction and retrofit markets, our systems are non-load bearing, fully insulated, non-combustible, and ship complete with windows and exterior cladding factory installed. We are a NYSERDA approved component manufacturer through the Retrofit New York program, and we are third-party tested to ASTM, AMA, and NFRC standards. Next slide, please. At this point, I'm going to hand the microphone over to my colleague, Alexandra. What Alexandra will discuss here is how the efficiency, which is one of our primary pillars here at the company, the efficiency goes beyond the performance and installation of our panels and really boils down to the technology that's really driving the industry. So Alexandra, if you don't mind, I'll turn it over to you and you can speak to Dextel Studio.
Absolutely. Thank you, James. Good morning, everyone. Our software, Dextel Studio, integrates with the construction project's ecosystem, optimizing Dextel panels to meet project requirements and facilitating efficient collaboration, helping to reduce material waste and embodied carbon. It seamlessly connects all project stages from the facade design to its installation and maintenance. This platform links the parameters of the Dextel unitized wall system, the intended architecture design, and project specifications, keeping it within the budget. As a part of our Design Assist service, it streamlines workflow and communication among all stakeholders. It provides transparency and communication, empowering teams to make informed decisions by providing access to real-time data and insights. It delivers detailed analytics and reporting on project performance, including timelines, budgets, and resource utilization. It generates outputs for construction documentation, shop drawings, submittals, and reports. It also has QR codes that integrate with Dextel products installation and maintenance, which incorporates real-time monitoring and feedback mechanism to identify and address issues. The software offers panel and cladding optimization, which utilizes algorithms to optimize performance and reduce material waste by up to 30%. Thank you.
Next slide, please. The next pillar our company is built on is based around affordability. On average, the first cost of our system comparative to on-site built wall construction is 15% less. The larger recognized savings are found through the utilization of smaller crews to install our facades, and also the speed of which our panels are installed. In this particular case, the general contractor and owner are reporting that they will finish this project 3 months ahead of schedule. And you can imagine, with the interest rates being what they are, the carrying cost on this loan and having the ability to fill these apartments quicker, that resulted in almost $1 million cost reduction versus the original plan to do on-site built walls. Next slide, please. And last but not least, the sustainability aspect of Dextel, our third and final pillar. In this image, you're seeing a project in Queens called the Metropolitan, and we had a life cycle assessment study conducted by a third party. And what was discovered is that comparative to on-site built walls, the embodied carbon or the embodied impact, there was a significant reduction, as you can see, by 90% in average construction waste. And overall, there was a 43% reduction in the embodied carbon footprint. As the operational impact, we don't have, the building, it's just being completed. We don't have any empirical data. However, just plugging numbers in comparative to code compliant walls into the ComCheck, what we have revealed is that in a 1-bedroom apartment here in this project, there was a 39% improvement in the heat loading efficiency, and also an 11% improvement in the net cooling load efficiency. And for the average apartment size, a 22% improvement in the overall heating performance. Next slide, please. Here you're seeing a case study in New York City. Some of you might be familiar with it. This is the Heritage, or otherwise known as 1660 Madison Avenue. This is a Mitchell-Lama building built in 1974. Some of the challenges faced here are, just really its poor insulation, utilizing natural gas to fire the hot water, and inefficient baseboard heating. And as you can see through the facade, the fenestration, there were some limited opportunities for daylighting as the building exists right now. So with some of the design enhancements and facade modification, as you look to the right, that is effectively what the building will look like. So the Heritage was the recipient of an Empire Building Challenge Award, as it will be carbon neutral through the envelope upgrades offered by Dextel and combining high performance windows, which will reduce energy, add daylight, and increase indoor comfort. And the heating and cooling will be provided through package terminal heat pumps. Next slide, please. And we'll finish on some research and development projects that we're currently involved with right now. On the left, you'll see a rendering of our integrated heat pump. This is something that will be available in 2024 to have a integrated heat pump within the system. And on the right, what we're showing there is building integrated photovoltaic system, which is all factory installed, saving time and money on the job site. And there are also incentives for this type of system, but really what we're offering here are holistic solutions to the building industry. And I will conclude with that. Next slide. We appreciate your time and look forward to speaking to you, and I'll do my best to answer any questions that come up in the chat. Thank you very much.
Thank you, James and Alexandra. Much appreciated. Our final presenter is David Goldstein with Hydronic Shell Technologies, an emerging technology solution. David, please go ahead.
Okay, well, thank you, Larry, and hi, everyone. I'm happy to just give you a quick peek into the technology that we're developing to help address this decarbonization challenge. So Larry, next slide, please. So our focus is on masonry multifamily buildings built pre-1980, so like the one you see here on the left. And we really approach this challenge from 3 different perspectives. So obviously, whatever we do has to be technically viable in terms of achieving decarbonization. But that's usually actually the easy part. Much more difficult is getting the economics to work in terms of actually providing a good return on investment for this upgrade work. And then sometimes the biggest challenge is actually just the logistical aspect of all this, because when we retrofit these buildings, for the most part, the tenants are going to be in place. And doing work with tenants in place can be a real logistical nightmare. And so for many buildings, that's actually the biggest challenge. Next slide, please. So we know that these old buildings, they were built before energy codes even existed, and we know they need major envelope and HVAC upgrades. So Larry, click next, please. So our solution is to integrate the two, integrate the facade and the HVAC into a new exterior shell that's essentially like wrapping the building in a heated blanket. So it's installed non-invasively from the exterior, and it happens to be a much more efficient and much more comfortable way to heat a building. Next slide. And we've developed this concept into a comprehensive solution that also includes central cooling and conditioned ventilation air. So it's a huge upgrade to the building's efficiency, but also to indoor air quality and thermal comfort, and even a major upgrade to the building's appearance with this new outer shell. So to us, it's about much more than just decarbonization, but it's really about modernizing these older buildings and increasing their value for decades to come. Next slide, please. This concept of wrapping a building in an insulated shell is not new. Europe has already gotten pretty good at it with their Energy Strong program. And there's a big push to replicate that success here in the US. And you just saw it with Dextel, because Dextel is probably the leader or one of the leaders in this space. And so the work that we're doing at Hydronic Shell is to build upon that existing overclad technology by fully integrating our modular HVAC system into it. Next slide, please. So here's what the hydronic shell actually looks like. So on the left, you see we're putting new central equipment, ventilation and heat pumps producing hot and chilled water up on the roof. And we run the distribution down within that new facade. And then in the center here, you see what one of these modular panels looks like. And our HVAC component, the Hydrobox, sits on that panel right below the window. And then on the right, you can see how this panel gets installed over the existing facade. The existing window is removed, and so that Hydrobox is able to supply the conditioned air into the space. And then in addition to the Hydrobox, we have the heating element sitting under the Hydrobox, and that's actually what creates this heated blanket effect. So the warmth will actually radiate into the apartment going through that existing uninsulated masonry wall. Next slide. So that was an example with central equipment up on the roof, but there's other options for the central equipment. And one good opportunity is with geothermal systems or with central district thermal networks. Because there's big opportunity for that, you know, in a dense area like New York City. And what we do is we help solve that challenge of how do you take the heating and cooling from that central network and actually distribute it to all the apartments in the building. So next slide. And here we have just a quick 30-second video showing what the installation would look like. So we see here installing those risers, the ducts and pipes from the equipment on the roof, and removing those existing windows. And then we install these modular panels, just like those Dextel panels on the exterior. And we have our Hydrobox integrated into those panels. So after you install it, you now have pretty simple, easy connections from those panels to the risers, and then you install the remaining panels over the risers. Next slide. Now, for us, it really, the economics is huge. In order for any solution to scale, you know, the economics have to really be attractive. And so for us, that means for a project, it should be able to be fully financed and have operational cost savings exceed the cost of financing. So this way we can offer it as a turnkey solution where the owner pays no money out of pocket and they see net savings from day one. So the idea here is we want this to be something building owners actually want to do instead of something that they're forced to do because of legislation. Next slide, please. Now, I have to mention that this solution is not for every multifamily building. So if you have a historic facade that you don't want to cover up, if you have a very complex geometry, or if you have really large window areas, then hydronic shell might not be the best solution. Also, there could be issues with zoning restrictions if they don't allow you to add thickness to the existing building. You know, for example, if you're a building on a lot line, you might not be able to do this. So really, each building needs to be evaluated to see if it's a good fit. Next slide, please. And so just wrapping up here, I should mention that this technology is not available yet. We expect it to be commercially available once we're done with our first demonstration projects, which should be in the next few years. This image on the left is a building in Syracuse where we're planning our first demonstration, though we're definitely interested in other demonstration sites as well. And then just really quickly, last thing I want to say is just the importance of dialogue between people like us doing the R&D and the building owners, the contractors, the designers out there, because the more we talk now and the more we can get your input, then the better these solutions will be at actually meeting your needs. So let's keep this dialogue going. And thank you, Larry, and back to you.
Great, thank you, David. Okay, so we're now in the Q&A part of our webinar. We've got about 9 minutes, and I'd like to just start with a question to each of the presenters in 30 seconds or so, starting with Hugo at Adler Windows. How long would you say a project would take from initial contact through evaluation to installation for a window replacement?
30 seconds. Thanks for the question. It's a open-ended question, just because it depends on the complexity of the project in product type and scale or size. But give yourself, it's never too early is a short answer, but roughly 6 months to evaluate a project, price it, promote the right product. Fabrication can be anywhere from as short as 10 weeks to as long as 35 weeks, depending on the system itself. And then installation can vary depending on the size and, again, the complexity of the installation. We never pull a window out unless we can put a window in the same day.
Okay, that's really helpful. Yeah. Cindero, what about for one of your typical projects?
So it usually takes somewhere between 5 to 10 business days to actually get the material. And then once we're actually on site, on average, you're looking roughly about 20 minutes per window, and that involves cleaning the window, prepping the window, cutting the film, and installing the film.
Great, good insight. Thanks. Tom, for an InnoViews project?
The way we work is data driven, right? So we get the data back from the customer, do a building walk, provide the cost benefit analysis, and then typically we'll install a mock-up. And to get a mock-up from the time that we get all the data back is usually about 6 weeks to get it installed. But everything is prefabricated down in Texas, then shipped directly to the site. Once the mock-up is installed and the customer makes a decision, and we provide the rebate paperwork into the utility. It usually takes about 30 to 60 days to get the PIOL back, and then it's off to a contract. I'd say in a major high-rise building, it's anywhere, total project time is probably about 6 months to 8 months, depending upon what type of retrofit, if it's an exterior or an interior. But the leading edge piece is the decision by the owner.
Got it. Very good. James, I'm sure a Dextel project, design, fabrication, installation probably takes some initial work, then to the design studio, and then to the field.
Yes, thank you, Larry. So, this is kind of a loaded question, but I'll try to summarize. I have one new construction project. Conversation started late 2022, and that project was in CDs already. We want to be involved in the project from the early massing stages and schematics. That wasn't possible, but that project in Brooklyn will be installed midsummer of this year. So that moved rather quickly. As Alexandra had presented our Dextel Studio program, that's really where we're going to save the time with the design coordination process. It could be, down from 2 years to a couple of months. And we are providing design assist services at no extra cost. So I would say on average, 6 to 18 months when you factor in, design assist, shop drawings, production, delivery. I'll leave the installation side up to Hugo, who, by the way, will be our chosen installation partner on the 1660 Madison project, which will be installed midsummer. With the retrofit projects, what we have found is that, there's a lot of upfront engineering, and that's done through 3D scans, building probes, so on and so forth. The 1660 Madison project, I believe the conversation started about a year ago. So maybe about 12 months. And as I said, we'll see panels being installed on that project midsummer. So I would say on average, maybe 9 to 12 months. Everything is subjective to reviews, and there's only so much that we can control, as everybody understands. Thank you.
Yeah, thanks so much. And David, for hydronic shell, you had mentioned the Syracuse trial site and looking for some others. What kind of time frame would you say for implementing these initial trial sites?
Yeah, so of course, with these kind of demonstration projects with a new technology, the execution time is a lot more than it will ultimately be once it's a commercial product. But it really starts with just looking at the building and seeing if it's appropriate or not. And that evaluation can often be done just by looking at Google Earth, and in a few minutes you can tell if the building is likely to be a good candidate or not. So that initial evaluation is very quick. Then to actually execute the demonstration project, probably looking at a period of at least a couple of years, because there's going to be a lot of planning, preparation that's going to go into it before the actual installation itself. Again, because it is a demonstration project with a new technology.